and welcome back to another lecture in the Mathematical Methods course. What we are looking at today is, the last thing in this lecture. It is called proportions. Now, what is a proportion? Well, it's kind of exactly what you think it is. It's a proportion. It's the number of things out of the total that have a certain characteristic. And we have sample proportions and we have population proportions, okay? By this point, you should be familiar with the words sample and population, but I'll just go over them one more time. Sample proportions are the proportions you get from your sampling. Population proportion is the actual proportion. So to give an example, let's go back to our music thingy. So we found a bunch of sample proportions in that case. You know how we did those things where we got 25%, 50%, 10%, okay? Those are proportions, okay? And then we went on to do different things with sample means and stuff like that. That doesn't kind of play as much here, okay? That is a different sort of sampling. This is a different sort of sampling. Here we're looking at proportions instead of means, okay? So we got stuff like 25%, 50%, okay? So that is what a sample proportion is. And your population proportion is the proportion of the entire population. So in our case, it would be out of the billion songs, how many of them actually have, what percentage of them actually have a catchy chorus or actually hit songs, okay? And we denote that by P, okay? More on notation, we denote the sample proportion with P hat, okay? So that is what we do then. Now, as we had for the sample means, we have a similar sort of thing here. We say that as n, your sample size, gets bigger, P hat is more normally distributed, okay? And if n is sufficiently large, okay, P hat has the mean P, okay, so the population proportion, and the standard deviation of P, 1 take P, all over n, all square rooted. I believe, let me just make sure I'm not doing this incorrectly. Yep, so that is your formula, okay? But unlike the sample means, we actually have a condition here, all right? A general rule of thumb is that n is sufficiently large if np is greater than 5 or n 1 take p is greater than equal to 5. Okay, so if these two conditions are met, your p is normally distributed and has the mean as standard deviation that has been mentioned here. Okay, now coming back to our thing of guessing something about the actual population. Same thing as before, we use confidence intervals, except this time it looks a bit similar but a bit different, okay? P, which is the population proportion, is less than equal to P hat plus P hat over P hat times 1 take P hat all over n. And P is greater than P hat take P hat 1 take P hat all over n. Oh, I forgot the z's. Sorry. Okay, Z does the same thing as before. It gives you your confidence, all right? The bigger the Z, the more confident you are, all right? And all the same things apply again. And everything that I said before about how the greater the sample size, the more accurate, the more smaller your width, all of that comes back into play again. And all of that still applies. And all of that is all you need to know. Okay, so now you can estimate the actual proportion of songs or whatever it is. More importantly, you know everything about sampling, you know everything about proportions, you know everything about mathematical methods. It says. All you need to do now is do a lot of questions, especially the ones after this, all right? You need to do some mock tests, you need to do some exams. If you have any questions, the mentors are always there, the tutors are always there, ready to help you, experts in this field, and very lovely people. So just go there, talk to them, get your queries solved, and be ready for the exam so you can smash whatever target you had at the start of the course. Okay, so good luck with that. Do some questions, and hopefully you get a good result. That'll be me signing off.